Hi, I am Alper Yazar. Welcome to the third part of the video series about my isoUSBRS422 project. This video is for makers who want to make his or her own isoUSBRS422 board copy. In this video, I will talk about my recommendations about production, actually soldering. Enjoy the video. After you obtain the PCB and components, next you solder them. You may use reflow oven if you have it. Also you can solder by hand like me. Pitch of the smallest component is 0.5 mm. For me, it's not so easy to solder this component, but obviously it's possible to do it. I will give some recommendations by showing some pictures taken during soldering of my second isoUSBRS422 board copy with serial number 2 and this board. If you like, you can follow my order. Let's get started. I usually use separate anti-static bags for each type of component. Quantities are given in BAM. When I solder, I finish all components in a single bag. Then I move to the next. For example, I finish all 10K resistors, then solder all 1K resistors, and so on. I put away empty bags to keep my workspace clean. After preparation, if you have to postpone soldering, you may use a large bag to put all component bags and PCB in it and paste a label on it. Before soldering, you should check both sides of PCB for defects and clean them. For cleaning, you may use some deflux solvents or isopropyl alcohol with good ventilation. Make sure that there is no contamination on pads. Most of the components are placed on the solder side. I recommend you to solder all components on the solder side, then solder the component side. If you start with component side, your board will not stay straight when you start to solder the solder side on your desk. You will put more effort into soldering. Components with the smallest pin pitch are U102, U103 and U105. Since there isn't any other component, you can use your iron easily. Then solder passives around those components. For example, you can see the resistors around those ICs. Finish all resistors and components on the solder side. Then finish all components on the solder side except ICs. Finally, solder the remaining ones on the solder side. Before moving on the component side, I quickly do a short test. Because if you have shorts or solder beads on the solder side, it's much more easier to fix them before soldering the component side. First, I measure the resistance between the nets, 5V USB and ground. I read typically 12.8 kilo ohms. You can see the touch points of probes. I use pads of the USB connector. Then I measure the resistance between plus 2.2 volt and ground. I read approximately 267 kilo ohms between these two lines. I use this wire and this pad for positive and negative probes respectively. Finally, I check the resistance between plus 5 volt USB and 3.3 volt lines. For this particular board, I measure approximately 245 kilo ohms. I use pad of USB connector and this wire for positive and negative probes respectively. If everything is fine, finish all components except the USB connector. I don't have a controlled and well-protected USB port in my setup. Before plugging the board to computer, I want to make sure that it doesn't draw excessive current. I solder two wires to 5 volt USB and ground pads of the USB connector to test the board. I do a final resistance check between two wires. Remember that components on the component size were missing at the last measurement, and it looks still good. Then I apply 100 mA limited 5 volt to the board. As you can see, on and RX LEDs glow and board draws approximately 22 mA from the power supply. As I mentioned in previous videos, you have to program the board with proper settings to use it as an USB converter board. However, with default settings, RX LED glows when the USB chip is in sleep mode. Since the board isn't connected to a real USB device, it's in sleep mode and LED glows. Finally, desolder wires and solder the USB connector. And you are done. Your board is ready to program. In the following video, I will talk about programming, driver installation, and doing functional tests. See you.